Hello everybody. What I'd like to try to explain today is how you can solve a quadratic function using the zero products property. Now here's the first thing to understand. You can't solve a quadratic function. Its job is to take an input and turn it into an output. There isn't a solution. In order to solve it, it would have to be an equation. So we're going to take this function, we're going to change it up. So it's not a function anymore, it's an equation. You can solve an equation. You can come up with a solution for it. In fact, there'll be two solutions for this one. But the only way it works with quadratics is if that function is equal to zero. When it's equal to zero, we can use what's called the zero products property to figure out what is the number that I can plug into this equation to come up with a solution. Here's the deal though. I can't do it when there's an x squared and an x. In order to make this work, I have to take it apart. I have to factor it. So I'm going to factor this quadratic apart. You'll recall that we can do this by brute force. It'll be x and x. They'll both be negative because that's negative and they must be the same. And the two numbers that multiply to make 10 and add to make negative 7 are negative 5 and negative 2. All I've done is taken this apart. It's still equal to 0. But if I have two things that are multiplied and they equal to 0, then one of those two things has to be 0. So I'm going to assume either this is 0 or this is 0. X minus 5 is 0 or x minus 2 is 0. So I'll solve this equation. I'll add 5 to both sides and find that x is 5. And I'll solve this equation. I'll add 2 to both sides and find that x is 2. Those are my two solutions. X can't be both 5 and 2 at the same time. But if x was 5 and you plugged into this function, you'd get 0. Or if x was 2 and plugged it into this function, you'd get 0. These are your two solutions. Factor, set each of the factors equal to 0, and solve to find out what each value of x is. Let's try it again with a slightly harder one. 2x squared minus 7x minus 15. Solve this function. Oh wait, I can't because it's not an equation. I need to make it an equation, which means I need to set it equal to 0. And if it wasn't easy to set equal to 0, I could do a little bit of forcing around to make it equal to 0. But for now, I can just say, hey, what if it was equal to 0? Let's solve that. Same deal. I have to take it apart so that I can apply the zero products property, which means I need to factor this, which isn't going to be as much fun. It has a leading coefficient. Fortunately, I have tools. The star method will take this one apart for me. 2 times negative 15 is going to be the top of the star. Negative 7 is what goes bottom. 2 and 2 fills the armpits. So now I need the two numbers that when I multiply them, I get negative 30. When I add them, I get negative 7. I'm pretty sure that that's negative 10 and positive 3. Simplify this like it's a fraction. You get 1 over negative 5, 2 over 3. So my two factors are 1x minus 5 and 2x plus 3. Take it apart. Remember, it's all equal to 0. So this is equal to 0. And this is the new bit. If these multiply and make 0, then one of them has to be 0. So let's say x minus 5 is 0. Add 5 to both sides, and x must be 5. Or 2x plus 3 is equal to 0. This will be a little tougher to solve, right? We'll have to subtract 3 from both sides. So 2x equals negative 3. And then we'll divide both sides by 2 to find x is negative 3 over 2 or negative 1.5. There are my two solutions. What do those mean? Let me show you. If I were to put this function on a graph, I know that it crosses the x-axis because its 0 x values are these two numbers at negative 1.5 and positive 5. I know this function looks more or less like this. That's the zero products property. Set your function equal to 0, factor it apart, and then take each of the two factors and set them equal to 0. Solve each one, and the solution to each one of those is one of the two solutions to your original quadratic, the two zeros to that function.
Don't bother me, I'm working.